So last time in college algebra, we were doing solving systems of equations. Today, same, but just story problems. My math lab is going to tell you how to do them a certain way. We are going to override that with common sense. Right? Sometimes they say use substitution. Sometimes they say this. Sometimes they say graph it. We are going to do it the easiest way possible. Sound good? So first, here's our story. I'll let you read that. And on your worksheet, it literally says, my math lab says use graphical methods. Right? This is kind of an old slideshow. We are not going to graph these. It takes too long to graph. It's not that it's hard. It just takes too long. We'd have to find the right window. This has a y-intercept of 1,192.5, right? It's just like you have to change the window, do all that stuff. We're going to use algebra. Algebra is so much faster to solve this, right? So first, help me. If something's going to break even, if a company's going to break even, you got your revenue, which money coming in, and you got your cost, which is how much you're spending. How do you break even? They equal each other, right? The money you spend is the same as the money that you came in, right? That's breaking even, right? Revenue equals cost. R equals C. That means substitute, dude. Where there is an R, can't you totally substitute that in for C in that case? So 8975 x equals 2350x plus extra stuff. Because they want to break even, the revenue and the cost should be equal to each other. So we'll set them equal to each other. And we'll do a little subtraction. So we get 6625x equals 1192.50. And then we'll divide 1192.50 divided by 6625. And I got 18. Right? Would you believe that that didn't take much at all to do? Just algebra. It's like, why graph that and spend 3 minutes trying to find the right window? Then you got to find where they intersect. It's like algebra is faster, right? So 18 bracelets. If we were taking a test, you need a label on that, right? 18 bracelets is what it was all about. Okay with that? Do the next one. Number of active people in the U.S. Navy, right, in thousands, is given by this formula. And the number of active people in the Air Force is given by this formula, where X is the number of years after 1960, right? So use graphical methods. I even think I typed it out. No, we're not going to use graphical methods to solve this. We are going to use algebra to see when the people in the Navy reach the number of people in the Air Force. Set them equal to each other, right? Set them equal to each other. One of them's about Navy. The other one's about Air Force. They want to know when they are equal to. So you do all your algebra. Right? You know, blah, 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 blah. Move this over, move that over. You can do that at home in video land. And you should get X to come out kind of nasty. Did it come out nasty this time? That can happen, right? So let's say X is about 27.2-ish. Is that what you're kind of getting? 27.2. Then we got to go answer the question. It says, find the year at which the Navy reached the Air Force. X up here stands for years after 1960, right? This is 27 point blah, blah, blah years, right? So let's just call it 27. You down with that? 27 years after 1960. What year are we in? 1987 is the answer to that question, right? 1987. How many were in the service when the numbers were equal? So we got to take this nasty number that's probably in your calculator, right? So we probably shouldn't round it off, like have that number in your calculator and substitute it back in, and let's like find the y value. Which equation do you substitute it back into? It doesn't matter, right? You set them equal to each other, right? That's what the system is. It's like you solve for x, that you sub back in. So take the nasty number that was in your calculator and just use your previous answer button to do that. So whatever. You should get like 521.79-ish. Is that what you're kind of getting? 521.79-ish. So to answer the question, though, remember they say that was in thousands. So we'll have to move this. How many zeros does the number 1,000 have in it? 3 zeros. So we got to move the decimal 3 decimal places. So it's about 521,790-ish. You'll just have to round how my math lab tells you to round. You know, if they say round to the nearest 1,000 or round to the nearest whatever, they'll tell you how to round. So if they say round to the nearest thousand, it'd be like 522,000, or whatever. So you cool with that idea? It's just solving a system. Once you find x, you substitute back in, and you find y. Those are just system story problems that we haven't done a lot of in your math past. The next few, we have done a lot of them. First one is a mixture. So we got a mixture, and they're mixing together some cc's. It's just a unit of measure, like I was doing ounces, cc's, of some sort of medicine. They don't even tell us what it is. But they give us 3%, right? You got an 8%, a 10%, and a 5%. Let's discuss right now which two of those get mixed together. Is it possible to take the 8% and the 5%, mix them together, and get 10% back? Can you take, let's call them low, medium, and high. Can you take the low amount and a medium amount and get the high one back? Which two of the three do you have to mix together? The high and the, those are the ones getting mixed together. Just like I did 0% water, or 0% coffee and 10% coffee, mix them together, I get something in between there, right? So when you do story problems for me, y'all, we have to define variables first. And that's tough for a lot of students. We are going to not just define them, we're going to accurately define them. We're going to let x equal, instead of saying amount, they give us an amount. How about we do cc's of 10% and y be the cc's of the 5%. How did I know to use those two? Because those are the ones getting mixed together. That's the high and the low. It doesn't matter which one's which, but I got to mix the 10% together and the 5% together, and they're going to get a mixture of 8% back is what they want. All right? So high and low are going to be your two variables. Then they want us to set up a system, so you'll get points by writing your equations. The first one is the one that's so plain Jane, it's so easy that it's kind of hard. Would you believe out of the four numbers they give us, this first guy does not have any percents with it, right? It is the amount of cc's. And way back in freshman year, when you were first very new at algebra, it's like I would ask a question like this. Okay, how many cc's of the 10% are they pouring into the cup or whatever? And people go, I don't know. I go, I know we don't know. We made something up for it. How many cc's of the 10% are we putting into the cup? Please say X. How many cc's are we putting in? X. How many cc's of the 5% are we putting in? Y. And they're all supposed to add together to be 100. Can we write an equation for that? X plus y equals 100. Again, it's so basic that it's hard. But it's cc's plus cc's equals cc's. We have X cc's of 10% solution plus Y cc's of 5% solution should all add together to be 100 cc's. Just like here, 2 ounces of water plus 2 ounces of coffee added together to be 4 ounces total, right? You just knew the amount that I put in there first. I don't know how much 10%, so it was X. I don't know how much 5%, so it was Y, but they all add up to be the grand total of 100 cc's. Cool with that. Then the percents come in. So 10% of all this plus 5%. Oh, be careful with that 5%. Is it 0.5 or 0.05? Yeah, watch that. It happens to the best of us. 0.5 is 50%. They're supposed to add together to be 8%. Now, here's the trick. 8% of what? 8% of the whole thing. The whole thing is how many cc's? 100. So we got to always, in a mixture problem, bring whatever our total amount is down here and multiply it times our percentage. Like 8% of all 100 cc's of that is supposed to have the medicine in it, right? So 8% of the total. And now, this is where we will use common sense to solve this system. Would you like to do this by graphing, substitution, elimination, or use a matrix? What would be the easiest way? Matrix should be the easiest way. It's not bad to do elimination, but you got to do crazy multiply numbers, right? Well, let's use a matrix. So let's go to second matrix, and this is going to be a 2 by 3 matrix because there's 2 rows by 3 columns. And then we'll do 1, 1, 100. And then 0.1, yeah, you don't need the 0, but you can have the 0. 0.05, watch that. And then in the last spot, let me make this large so you can see it, you could either figure out ahead of time what 8% of 100 is, or you could literally just type 0.08 times 100, and it will figure it out for you in that spot. So you can just type that in there, and it'll figure out that it's 8. You know? So whatever you want to do, figure it out ahead of time or let it do the work for you. Then we'll quit out of it and do some reduced row echelon form on it. So second matrix, we go over to math. Option B is in boy for reduced row echelon form. And go choose our matrix. Mine is matrix A, whatever yours is. It could be a different letter. And get our, solutions matrix. This is what you got to write down. Notice I did not write a augmented matrix down at all. You know, it's like, to me, I don't need that. But the the solutions matrix, I want that. The one with the ones and the zeros. And what was it, 60-40 or 40-60? 60-40. So got to have this, right? That's worth points also. And then we've got to answer the question. It's not just an ordered pair of 60-40. 60 what, 40 what, it's back here, right? 60 what? cc's of 10% solution. You don't have to write the word solution. 60 cc's of the 10% and 40 cc's of the 5%. So mixture problems are weird, especially if you haven't done them in a long, long time. We define our variables first. Then we write our equations, which I'm happy to help you with if you need help with that. Let the matrix do the work. Get this and answer our question. Okay? Why don't you read this guy? We'll see. Bring him. The best thing to do after you've read it is to go find the question. What are they asking? This is not a mixture problem, by the way, because they don't give me any percents. Right? Would you agree all of those numbers are just normal, no percents? Right? So we're not mixing anything together. So this is back old school. What's the question? Down here. How many glasses of skim milk and how many quarter-pound servings of meat will provide this? Let's be as accurate as we can, but still not write a novel here. So I don't care what you use. I'm going to do X's like glasses of milk, and Y is quarter-pound servings of meat. I did abbreviate a little bit, but I do want us to be accurate. I'm not a fan of X equals milk, Y equals meat. You know, it's like, what about the milk? What about the meat? Glasses and servings, you know. So we'll define our variables. So in that story, there was 4 major players. There was milk, there was meat, and there was 2 other concepts. What else was in there besides milk and meat? Protein and iron. How did I know to use these 2 as my variables, though? Because that's what the question asked me. They asked me about milk. They asked me about meat. What that means about the other 2, the protein and the iron, is we probably need a protein equation, and we probably need an iron equation. So if it helps you to make notes, let's start with a protein equation. Protein. Like protein plus protein should equal protein kind of thing. I might have spelled it wrong, but still. Protein plus protein, I did spell it wrong, should equal protein. So let's go with the skim milk. Skim milk gives us 0.1 milligrams of iron, don't care about that, and 8.5 grams of protein. So protein, don't I get 8.5 from milk? What can I put next to that? X. Like every time I drink a glass of milk or whatever, you know, I'd get 8.5 grams of protein, right? Since X is how many glasses of milk, whatever. Plus, I'm going to get some protein from the meat also. A quarter pound of lean meat provides this much iron. Okay, I'm not talking about iron. We're talking about protein. Don't you get 22 grams of protein for every piece of quarter pound meat that you eat, right? And that should equal, according to this person's special diet, they need to have so many grams of protein in their diet. That is 69.5. How do you feel about that? Protein plus protein equals protein, right? See if you can write an iron equation. I don't care if you put the word iron off to the side. That's up to you. But iron plus iron should equal iron. See if you can write that equation. And keep your X's lined up and your Y's lined up. You know, that helps also. Come on, pen, work for me. My pen would work a little nicer if I read a little bit better, but how about 0.1x plus 3.4y equals 7.1? How would you solve this system? Crazy decimals to me means matrix. Right? It's linear. There's no squares or anything like that, so let's use a matrix. We'll get that punched in. I got it all into my matrix. If you need help with that out in the video, let me know. I'll help you punch that into the matrix. Right? But then I'm going to quit out of it and do reduced our echelon form on it, which was my previous entry. So I hit that, and I got this. Right? So that is my solutions matrix. I will write that down. Sometimes you can get a decimally one. You know, that might make sense for the context of the problem, but usually you don't. So if you get a weird answer, I go double check that I punched my numbers into the matrix right, and if that's not right, or if they all are right, maybe I wrote the equation wrong. 3 what? 3 glasses of skimmed milk is what you write out, and 2 quarter-pound servings of meat. Like, I'm expecting you to write that out on the quizzes and the tests. Make sense? So, nice. Old school, we've done a lot of those, but the matrix. I also should have said that to you last time someone came in and wanted some help with the system on my math lab, and they said, please solve it by elimination, and it was just full of decimals, right? And I was like, oh, my bad. It's like, you should just use a matrix on the decimally ones. If I want you to solve a system by elimination, it's going to be plain Jane vanilla, like you just got to multiply by 2 or something to cancel the variables out. So that's what I call using math common sense. It's like it would be so much easier to use a matrix on this than to do it by elimination. Okay? So last one. Read it. Read it. Find the question. How many seats? So we're talking about seats for our variables. How many different types of seats are they having in this theater? 3 different types. So we'll let x be one, y be another, and z be a third. Cool. And what's different about them? They don't have names. Isn't one of like their prices? You know, one's 40, one's 70, one's 100. So let's just roll it with like x is the number of $40 seats, y is the number of $70 seats, and z is the number of. Like, it's all about either number of or amount. You know, like that's the important part to me. But if you just say x equals 40, y equals 70, and z equals 100, I mark that wrong. In no way does x equal 40. You know, it's the number of seats. Then, while you're writing that down, we did problems like this back in Advanced Algebra 2, and these were the ones where we had some struggles. Writing the 3 equations. By the way, the number of variables you have is the number of equations you need to have. 3 variables, 3 equations. Right? Previously, 2 variables, 2 equations. Right? So I need 3 equations. 2 of them are going to be a piece of cake. The third one is the struggler. So let's talk about all of these numbers in here, boom, have dollar signs by them except for this one. This is the one that has no dollar sign with it. 3,600 what? Seats. So we're going to do like seats plus seats plus seats equals seats. How many $40 seats do they have? X. How many $70 seats? Y. And how many $100 seats? Z. So what do you want that first equation to be? X plus Y plus Z equals 3,600. We did not attach any of the prices with it. It is tempting to put 40x plus 70y plus 100z, but money has nothing to do with it. It's number of seats plus number of seats plus number of seats equals number of seats. Right? So now let's do a money one. Right? $40 for every $40 seat plus $70 for every $70 seat plus $100 for every $100 seat. When they sell out, do you know the total money that they should be getting? $192,000. Money plus money plus money equaled money. What I like to do right now is stop and ask you this question. What is your confidence level in these 2 equations being correct? Highly confident or not very confident? We should be pretty confident after a little bit of refresher, right? All right, these make good sense to me. It's that third equation where we got to go back and do the crazy math, language translating stuff. Let me move this over here. So here's what we got. He wants to have twice as many $40 tickets as the sum of the other types of tickets. They have to just throw this in there to make it complicated. Also, to use a matrix, we have to refresh our memory that everything should be lined up, like x's on top of x's, y's on top of y's, z's on top of z's, equals on top of equals, and numbers on top of numbers. With this, we probably better go off to the side because we're going to have to write an equation and then move stuff around. So he wants to have twice as many $40 tickets as the sum of the other two types of tickets. I'm going to give you a shot with your neighbor to go over here and see if you can translate that into math. If we make a mistake, we'll fix it. So give a shot. Well, we definitely know that we got to add the other two types of seat up, which is the y and the z, because this isn't the $40 seats to x's, right? So I got to take the y's and the z's and add them up. And what I do is I add them up, and don't I need to double that? So that's times 2. I would like that to be my $40 seats. This is the correct equation. And it is completely understandable if you did this. 2x equals y plus z. That's just complete backwards thinking, but I understand it because it's complicated. You can't double the $40 seats and then say that's what the other two should add together be. I needed to add together the other seats, and I got to double that because I want the $40 to be twice as much as these over here. So it's the green machine right here, which in no way can go into a matrix. Right, it's got parentheses in it. It's got all this other crazy stuff. So let's distribute the 2 through. So x is going to equal 2y plus 2z. And that still can't go in the matrix because it's not all lined up. Like hasn't ours went x, y, z equals number, right? I got the equal sign in the wrong place. I got to go x, y, z equals number. So I'm going to move the 2y over here and move the 2z over here. X is coming first. Boom. 2y coming over here, and it's got to be minus. 2z coming over here. It's got to be minus. And then here's the brain fart that happened to us all the time. There's nothing left over there. So what do you have to write down? A 0. Like you need that 0, right, to make that equation. Now you're ready to rock with the matrix. So we'll put it in the matrix and get our answer. So once again, if you need help with the matrix, let me know. I will show you how to punch that in. But this is what I got for a matrix. And here's what makes perfect sense. Here's how I know I most likely did this right. All of these are positive. Like if you get a negative amount, that means you made a mistake with an equation. And would you believe this is the equation you probably made a mistake with because you were very confident in the first one, you were very confident in the second one, but it's that third one, it's like, oh, it might be a little shaky on that. So if you get a negative amount, maybe go back and change something around in here. Even if you don't understand why you're changing it, try something else to get a positive amount. Would you believe they also add up to 3,600? You know, that's supposed to happen, you know. So if you get a negative, this equation was probably incorrect. And then you'd answer it $2,400 $40 seats, $800 $70 seats, and $400 $100 seats. So quick refresher of systems story problems. Let me know if you have any questions. Have a good one.